Last summer, one Saturday, I was watching the World Cup cricket match. I think some of you may be familiar, India versus England. I was watching that, and then I get a call. I get a call from a president of a major bank from New York. And I know I have been working with him for a while, and if I get a call, means there is really a serious issue. Right? So I take the call, and it was a payments issue that said, Surya, I really need your help. We had a major outage last Tuesday. We were talking on Saturday. So I want you to tell me what happened on Tuesday morning at 12 o'clock. Right? So that's how I got involved in this. So this is actually the second. In fact, I don't know what is it to do with these cricket matches, or maybe 2 years before, I was actually watching Super Bowl. And I got a call from the same bank, a CIO, saying, Surya, are you Patriots fan? I said, not really. Then I need your time, right? So there was a big crit set. So even though I'm from the lab, I do work with some of the major enterprise clients of ours. So good afternoon, everyone. My name is Surya Duggarala. I am an engineering guild leader responsible for architecting and hardening IBM Cloud Platform and services. So I work and direct our research teams and engineering teams to make sure that our IBM Cloud Platform is actually architected and using the latest technologies. And I think some of you might have come for KubeCon New York. I was talking about the open source and how to harden the open source. So I also work closely with multiple open source communities also. So today we are going to talk about, I'm going to share my experiences working with these major enterprise crit sets and hot issues, understanding how these issues are actually, because the specific payments issue that I'm going to be talking about, it's nothing to do with cloud. It's all on-premise data center. So as customers are actually moving from on-premise to the hybrid cloud, hybrid multi-cloud, if these kinds of issues were to occur there, are we taking care of those things proactively? So I'm going to explain about this crit set, and then we will talk about how we are building the cloud platform to foresee these kinds of issues, how much we can actually harden, and then make it easy for us to diagnose these things. So of course, the case study I'm going to go over, and then how are we hardening, because I may not be going into everything, but some major hardening processes for adoption of the cloud. And then gone are the days where hardware is seen as a commodity or a black box. I think some of you who were there in the previous session here, we were talking about infrastructure as code, right? That's actually from a software side. But also the infrastructure providers, the process designers, are actually looking at how do I design the processors themselves for container workloads, cloud workloads. So I'm going to be talking about what exactly we are actually working on. Again, I'm fortunate to work with not only Intel engineering teams, but also our own power designers on this. Lastly, when you have this open source, when you have the technologies in the, like cutting edge technologies like Knative or Istio, when you bring these things open source and we try to implement an enterprise hybrid multi-cloud, what exactly are we working on? What is the future? A little bit I'll be talking about. Those are the 4 things that I'll be covering. So before we get into what exactly happened, so before I got involved in this payments issue, as I said, Tuesday it happened and Saturday I got involved. So already there are 4 different teams involved, 4 different partners, their senior technical leaders, everybody was already there. The problem is gone, but people don't know what happened. So there is no way, there is no confidence that it may not happen again, right? That's exactly my job was to understand what happened and how can we mitigate those things. When you look at the payments, for instance, some of you who are working on a major payment system, you know how complicated the system is because it has to interact with many other systems, and also it has a very much high messaging. Like you can see, these are some of the characteristics. It is a heavy messaging. You have big payloads, like you'll be moving millions of dollars, and then you have a lot of queuing systems in there, and then it deals with heavy transactions because it has to work with multiple parties there, and of course the high throughput because you have a high volume. And you can clearly see the unique workflow demands it has because it has to settle the payments here, it has to work with the Fed systems. So it is really a complicated payments system. So this chart is not going to do any justice for that because I made it so simplified in this case because the system is very complicated. I wanted to showcase just who are all the parties involved in this. There are 4 distinct parties. The enterprise banking application development teams from the bank, that's one group. And then you have, there is a proprietary custom banking software, payment software. Of course, they use this object-oriented database. Of course, they have SQL, and it is basically designed for handling the messages. So that is the second party. And then they are using a third-party vendor for the storage, right? And then, of course, the Power itself, that's from IBM, right? So because all these applications are running on Power. So these are the 4 major parties that are actually working. Normally, what happens when you enter into any of these hot and critical situations, all of us know that quickly we'll become defensive, because we want to make sure that nothing wrong in my system. So that was exactly what was happening. So what happened? So what we did, I started working on that Saturday for a week or 10 days. What we found, it's not just one thing that caused this failure, but you had like 4 different things working perfectly together. They all came as a perfect storm. The first one is, of course, the thundering herd problem. And then we saw the DB database fragmentation, almost 100%. The database has become like fragmented to 100%. And then you have the misconfiguration, and then you have very inefficient storage. So how did we find? Actually, we took this thing, and it's very difficult to recreate that also, right? Because we had a QA, and then we tried to create all these inefficiencies, and then finally we could create that perfect storm once. So what exactly is a thundering herd? Some of you from a computer science point of view, right? And thundering herd is like, from a definition, when you have so many processes just waiting on a specific lock, right? Because that's actually the specific outward process doing that stuff. Once it is done, then all these processes are ready to take that lock and ready to work, right? So that is where you really see that there is a big rush of these threads or processes trying to get to, and then all of a sudden the system will become unstable. How did we find? You can clearly see that the system calls, almost 3.7 million system calls at that particular point suddenly, and then corresponding kernel CPU time, you can see it's spike of like 39%. So if you add up user and system, everything is like you're almost saturating the compute there. This is one, and why that is happening, why that specific lock is so much inflated. Then that has something to do with the other issue, database fragmentation. What was happening is, if you're using the object-oriented databases, 2 of the major things that you'll see is the object locking and fragmentation. So the fragmentation, to counter that fragmentation, because it's by design you will see fragmentation. Normally the vendors, they will try to come up with a defragmentation script. They will run that. What happened at this point was the defragmentation script was not able to cope up with the amount of traffic that we are getting, amount of messages we are sending. So that fragmentation is actually keep on accumulating to a point almost 100% fragmented database. Then obviously you can't do any outward processing, and that next to that is why that is also happening is because you have very inefficient storage system too. Because the third-party storage system that you're actually using, because of course you have the FC channel, like there's a fiber channel from the power box that will be talking to the third-party storage system. But what happened during the analysis, what we saw was it was not really using the third-party ODM file sets, because when you connect to a third-party solution, they will have an efficient way of managing the queues and the algorithms. So in this case, what we found was the admins and the operations, they didn't really use those file sets. So it's going by the default. So when you're using the default file sets, you will not get all these three different tunings that you normally get in a thing, right? For instance, the specific tuning parameter that I'm talking about is the queue algorithm. So it's actually taking the default, but it is not really reflecting the solution of the third party. And then the second one is the queue depth parameter, because when you're sending this concurrent massive load of transactions, the I/O channel was actually bound because you don't have the concurrency there. So because your queue depth is set as 8, and it is actually choking, so your LUN throughput is not increasing. So that actually impacted that outward, and that's why that lock is still there, because you're not able to, because there are so many processes trying to work, but you have that. So that is another thing. And then you have the PCM tuning. Some of you familiar with our power system, you will know that path control module, it determines two major things. It has the PCM algorithm. You have to set that for a equal I/O distribution, right? So that's one thing. And then there is an algorithm. You have to see whether between the round robin and the failover. So it was set inefficiently on that. So all these things are like operational manual kind of configurations. They're not efficient. So it's very difficult to find out all these things. So in addition to that, there are some human errors, like kind of when you're configuring stuff. What happened was in the earlier chart I showed, there is because people expect, because it's a very crucial system, so you have a hot standby. So when you see these kinds of fragmentation issues, you should be able to replace that. People did. But what happened because of some manual things, manual errors, they didn't put the disk ID correct. So then you can't write to any disk, so there are some disk I/O errors. So all these things came together as a big storm. And of course, right after this, I did work with even the third party, a couple of distinguished engineers from the third party storage solution, and everybody, we came up with a very nice way of actually further tuning and making sure that these kinds of things may not repeat. The reason I'm telling all these four different things, right? These are some of the things, not only the financial system, but I do work with healthcare, retail, and other customers as well. The problems may be manifested as a different things, but end of the day, they can be a manual configuration issues. They can be a database centric, fragmentation, or like all these problems, you can actually see them. So when somebody is actually trying to get to cloud, right, from on-premise with enterprise transactions, obviously they will be worried about, okay, what I'm going to deal with them, because here I can touch and feel because I can see it is right there, but in cloud there is no way you can find out. So these are some of the things that drive us when we are actually building these things. So I'm going to talk about some of the enterprise-centric concerns about this, right? One is the security and data integrity. One of the main things why people don't want to go to public cloud is security. And also they don't want to jeopardize their data, right? So because you have your main business value is locked in that data, and we don't want to lose that. And then, of course, 90+% of critical transactions, even now, they are being run in mainframe. Even though you have the other cloud and UI and other transactions, but the core airline, banking, everything is actually locked in, and it's actually it's running there, right? So how are you going to actually bring mainframe into this modern world of digital, like cloud? Right? And then you have the multi-cloud. You can see there are multiple clouds, because gone are the days where people are not able to, they don't want to put all their eggs in one basket, right? They want to make sure if some specific security issue or breach or something happens, they should be able to actually distribute the risk. So that's why people are going to the multi-cloud world. So when you have multi-cloud, how are you going to actually manage? You should be able to manage that as one single pane, so that you don't need to learn and actually get into the complexities of managing those things. And then, of course, the compliance and regulatory stuff is another thing, because if I'm a banker, I should be looking at the compliance and regulatory from the feds, and if there is a way somebody can flag any kind of compliance violation or something as a service, my life will be much easier. And one step further, if the cloud provider themselves are able to say that, okay, I'm going to certify this cloud for financial services, I'm able to certify this cloud for healthcare or for government, right? Then the whole risk is actually passed on from this, right? From a banker to this. So that is another thing. In fact, last week, IBM has announced a partnership with Bank of America, right? So that is one of the things that we are looking at. And then application modernization, because this whole conference is all about application modernization, right? We're talking about how the software is actually getting rewritten, and also the new frameworks and the new way of developing the applications, right? And then one very important thing is, this is where I will actually go a little bit deep into later on, is automation. When you go from an on-premise to, like all the issues that we have seen in that previous script set, you can see most of them are manual configuration settings and other things. How about, if I'm writing an application, if I'm deploying that application, I'm running that for like maybe in a year or 2 years, and I know how the application works, when I have to patch that, how I have to scale that, and all the operational knowledge. How about you take that operational knowledge and then code it, and then you deploy, when you're deploying that application along with the artifacts, if you can just get this operational knowledge also somehow in, that's exactly is the operators. So that way you are automating that application so that there is no manual intervention there. So let's get into the important one, that is the security, right? So there are two aspects here. Like, of course, when you look at security, there are 4 major things. The first one, of course, you have to manage the access so that the bad transactions are not getting in. First, you just stop right there. And then you have the protected data. Of course, you manage the access, the authentication, authorization, and then you have the, you protect the data, because data is crucial. As part of protecting the data, you have to manage the keys. So I'm going to go a little bit deep into that key management. And then, of course, once you have all this, you should have an insight or the visibility or observability of what exactly is happening, how you are actually able to audit if some breach were to happen, right? These are the 4 things when we talk about security. So what exactly is the key management, right? So these are the places where a lot of innovation is happening. In fact, the recent announcement with Bank of America is driven by one of these innovations that came from IBM. One of that is, let's say I was actually talking to a CIO, and he said, Surya, I have this data, so I want to have the control. Let's say, I put it on IBM Cloud or any cloud, right, for that matter. You put that on the cloud, and then, okay, what kind of things? So you're saying you have bring your own key, so I'll bring my own key. So I will encrypt it. But let's say if I have something, I put it in there, and then if feds were to come to you, what are you going to do? Are you able to showcase this data, or you'll be able to give them this data? Well, normally we won't look at your data because you can track it, but if feds were to subpoena me, of course I have to give it, right? That's the current thing people are a little bit worry about. But okay, is there other way you can do it? Yeah, we have other thing called keep your own key. If you don't want to even that thing to happen, then we have a feature called keep your own key. So what will happen is customer will bring their key, but even our own administrators may not have the access, will not have access. That's where you see the 2 aspects of technical assurance versus operational assurance. See, earlier I was talking about operational assurance, where IBM will not access your data. You can actually key that external certifications, you can trust visibility and all that, you can actually track them. But as you can see, IBM Ops can, if they are forced to by feds, they will be able to see and give the data. But if you see on the other side, like keep your own key, where you have technical assurance, IBM Ops, even if they want to, they cannot. See, those are the kinds of new things that are actually making it easy to get to this kind of financial cloud and other things. Okay, now that we are talking about security, see, normally when you have security, when we talk about 2 different things. One is the declarative security, the second one is the programmatic security. Declarative is like kind of a bolted on, you just have configure it, and you as a developer don't need to write any code for that. But sometimes what happens is you may, because if you're really, as a banking developer, if I look at how much time I'm spending to build a system, let's say if I'm spending 100 hours, out of that, my core business logic, the amount of time I'm spending on that is maybe around 65, 70 hours. But I will be spending 35 to 40 hours on providing the common services like traffic management, resiliency, security, all these things which are common. If somebody can provide that for me as a developer, my developer velocity will significantly improve, and in fact I can use that time to further differentiate my application. That's exactly where the service meshes come into play. Today I'm not going to talk much about the whole service mesh, but security, how the security is being handled by the service meshes. You can see there are multiple aspects, as I mentioned, about 4. All those things Istio can give it to you. A developer need not worry about anything. A developer can actually just run this and say, okay, in non-secured networks, you can run my application. You don't need to really think about that, right? So those kinds of things, if the service mesh can provide those things for you, then you're absolutely saving time, but also you are not really bothered about those qualities of service because somebody else is actually taking care of those things. When you put these 2 things together, you can clearly see that there is a data plane and a control plane. So data plane is where your microservices are running. So those microservices, you will have a sidecar proxy that will actually manage the whole things. Like, service to service, the one service doesn't know what the second service is actually doing, because everything, all the communication goes through the sidecar, right? So that's who will control the sidecar, who will provide the policies, who will provide all kinds of authentication, authorization, all that stuff. That's where the control plane is. So you can actually choose your perimeter, and you can actually look at the granularity also. Like, you can change, at what level, what namespace level you want to put to service level. So these are some of the new things that are actually coming in that we can actually get. So on top of this, you have, when you have these modern DevOps pipelines, right? So one way to, because one of the things that as a developer, I check in my code, and then if there is an automatic real-time check whether my specific changes that I'm making, whether they are causing any regression, any kind of regression stuff, if I'll be able to figure out and able to get online correction, that's where the modern CI/CD pipelines are really useful, because you have multiple phases, you can actually flag them, so those are modern CI/CD pipelines with a nice notification mechanism, because if I'm a pilot developer, if I see some kind of an issue, so I should be able to get to the pilot developers Slack channel. It'll go and say, okay guys, looks like you have caused like 20% regression from last night's build. Like, you dropped something and that caused 20%. So those kinds of real-time checks, gate checks we call it, that's the next step in the code quality of these cloud systems. Then I talked about mainframe, right? One of the things why people are like, if I'm a fresher coming from school, sometimes I may not be familiar with some of the tools, techniques, and processes of mainframe, like Endeavor tool or something, right? Then naturally I won't be able to work on, and I will try to go away from it. So how about, because as a computer science student, I'm familiar during my college itself that I know about GitHub, I know about all kinds of Jenkins and everything. How about we provide all these tools and techniques and processes on mainframe? Then you will be able to actually get these things. That's exactly what we are actually working on too. Then we're talking about operators, right? So as I said, operators are nothing but you're scripting the operational knowledge in and putting that in the operator that you deploy in the cloud platform, right? So when you are doing this, sometimes what happens is like, okay, how do I provide that knowledge and then put that? You have to be a Go programmer to get those controllers designed and translate your manual operational knowledge into the operator stuff. So we are trying to work on to make that easier. We are actually working on operator framework. There is an open source, it's easy for people to develop these logic and develop these operators. And in fact, I'll talk about how we are using these operators to make much more automated day two operations and all that stuff in our platform when I go there. So operators are actually catching up. If you go to operatorhub.io, you can clearly see there are so many operators are already there from multiple vendors and multiple categories you have, right? So you can actually, there is a Grafana operator, there is an Istio operator, there is an etcd operator, right? So these are becoming a norm, and this is how actually the automation is actually taking place. So go back to my earlier CritSet thing, right? So you can clearly see some of these configuration changes, some of the things that we have actually not, manual errors and stuff. If we can automate all these things and deploy it. And in fact, I will talk one level next futuristic stuff, right? Right now, you're actually manually getting a static way of putting this. How about put AI and DLAS concepts in this? So let's say I know for a specific CPU intensive workload or memory intensive workload or a data intensive workload, I need to do this to scale the system. If we can teach using DLAS, if we can teach the systems, okay, it will understand, it will learn, and then say, okay, I have, these are the 4 different scenarios, I did this, and then it can take its own decision if there is an unknown situation comes along. So those are the futuristic automation stuff with an with a autonomic computing with the DLAS, it's possible. So now let's get into the hardware design, right? So what I meant when, because the previous session was about, okay, how do I make infrastructure as code? Still, that is a software, right? But how about the hardware vendors are actually what they're doing right now, processor designers. They are getting to the let's say, Cube community and other communities from open source perspective. And then they're trying to see, okay, if you look at, for instance, from Moore's law and other specific requirements, right, from a CPU design perspective, we have reached the CPU compute level, right? Almost 4 gigahertz, you can't cross that because heat dissipation and stuff, right? So you have reached, from a compute point of view, you reach the max. You cannot go further from a gigahertz perspective. And from network, of course, you have like 100 and 200 gig, so you have a bigger pipe there too. But one thing that is not, still a bottleneck is the memory, because you can see that's still in gigabytes. How about you bring that to terabytes with the DRAM latency? That will open up a bigger opportunity for software, because now that's exactly what is happening with SCM. So if you look at this, the specific infrastructure things, right? First and foremost, when you provision anything, any VM, of course, the kind of virtualization technology you use, that will have a significant impact on how your application will perform. I'll give you a simple example. What we did, we were actually getting the Cloud Foundry at one point, like a few years back, 2 years back or so. We were moving the architecture from DEAs to Diego. So in the DEA timeframe, of course, Cloud Foundry uses Garden containers, right? It's like a different way of a Linux container. So previously on DES, we were able to pack 200 of those containers in one VM, right? But all of a sudden, when we changed the architecture to Diego, we were able to put only like 30. So 7x reduction. So now either you have to provide 7x more hardware to support the same kind of containers, or else you have to look at what is happening. So that's where we found out that for that particular kind of application, using PV or para-virtualized technology is really giving us the regression. The moment we change that from PV to HVM, just one change we're able to go past 200. See, these are the kinds of things from a virtualization technology, how it interacts with the cloud system, cloud fabric. Those are the things we really need to look at. And then SMT selection, right? Some of you are familiar with, there are different architectures, like from when it comes to x86 or Power, x86 is SMT2. So you have, per processor, you have 2 hardware threads, whereas Power has SMT8. You have 8 hardware threads per one processor. So certain high concurrent workloads may get benefited from these SMT8s. So if a cloud provider is providing both of those things, and if your specific application, based on the needs of that application, if there is a way you can actually direct the work to a right hardware architecture, that will really improve and improve your TCO and also increases the scalability. Of course, you have multiple things. You have, like the smart schedulers and inter-socket communication. So these are all the main pain points from a hardware perspective that hardware teams, chip designers are looking at to see that. So let me just give only a few of those examples. Some of you who worked on the data centers, traditional data centers, will know that if you want to eliminate inter-process communication latency, you would like to use some kind of a pinning, either pinning of a process or pinning of network interrupts. Those concepts actually worked very well, but how do you bring those concepts into Kubernetes? How do you bring those things into the cloud? That's exactly what the hardware vendors are working. For instance, if you look at CPU Manager for Kubernetes, so these are the things we're actually working where you can have an adapter you can initialize on a specific node, and then you can actually bring those concepts. And then, as I mentioned, different x86 are different power, and like you can do node tagging, for instance, to get the hardware profiles, right? So you can clearly say that, oh, I want my workload to run on this particular architecture. And then, of course, the persistent memory CSI plugin, like you have this the SCM, we call it as storage class memory. So that opened up significant opportunities for, let's say, you can really improve the container density or VM density by up to 40-50%. So that will directly impact your TCO. Right? That is one aspect. But SCM you can exploit in two ways. Either you can use the direct memory mode so that you don't need to do anything for your software, but you will get benefited just by using this technology. Or there is an app direct mode where you need to change your application so that you will use those opt-in or like the new kind of SCMs. So that will give significant, like maybe 2x, 3x, 10x sometimes, right? See, those are the kinds of new things that hardware innovations are actually helping improve the cloud solutions. And of course, I don't need to tell anything about the GPU plugins because that's the key for any AI and DLAS workloads, right? There's a lot of innovations happening there as well. So if you look at all these aspects, like innovation in the hardware and processors, innovation in the open source community, and getting the kind of issues that we are seeing in a traditional, whether it's a banking system or healthcare, if you bring all these things together, and then when you try to design a hybrid multi-cloud, that's what it looks like, right? We take all these different industry, our experience in these various industries, like the one that I explained about banking, and then we will come up with, when you talk about a hybrid multi-cloud, it is just basically, I divide this into 5 different parts. The big block that you're seeing is the cloud fabric. It can be anything. It can be a Kubernetes, it can be a proprietary VM, or it can be a Cloud Foundry, or in this case, we're talking about OpenShift container platform that is an enterprise Kubernetes, right? Of course, the traffic comes along. The first one is it enters is the front door, whether it is your data gateways or whether it is ingress gateways, you have firewalls. So it has to go through all that stuff, and then you have of course, your application will be bound to any public service, right? And then you may be interacting with the other SORs also, like systems of record. So when you look at these kinds of performance issues, see, those are the pain areas that you will really get the pain points there, right? So you need to really understand, it may be a latency issue talking to an external customer, or a latency issue talking to an on-prem LDAP or in MQ, right? So these are the things that you need to look at. So if you were to just take that fabric piece and then put it in, and then you can clearly see this, how operators are actually working. So now with CoreOS, with what OpenShift is trying to do is actually the operating system is managed through various operators. So Instead of having an operating system as one monolithic thing, you can container type, like you can make it into compute network system, and each one can be, you can actually do the automation using the operators in each one, and then you can have a bigger operators of operators. So we are taking the concept of operators to extreme to make the availability and also the kind of you want to patch or anything, right? You don't need to worry about all these things, or we are taking care. And this red piece can run on any cloud. This OCP, our OpenShift container platform, can run on IBM Cloud or Azure. So as a developer, I don't need to worry about anything because I can just shift from one cloud to another, and then you can exploit the hardware right below. And then your applications will be sitting on top with the cloud packs. Of course, this is, if you dissect this further, right, from a fabric, these are all the different open source technologies that are there, and we are looking into how these open source technologies, when they're actually taken into and implemented in the platform, how these things are actually working together without having any integration issues, and how we can actually scale this. Those are the things that we are working on. So in a nutshell, of course, cloud is getting hardened for enterprise security and data integrity solutions. And then, of course, you have the, operators are eliminating the manual errors. Of course, you have modern hardware is being used, architected for cloud specifically. And then, of course, mainframe is getting modernized and getting ready to come and work along with the cloud. And then, of course, the service meshes are really changing the game here for the microservices and application architectures. So if you want to know a little bit more, there is a think, build, grow stuff here happening. So tomorrow and the after, you can actually get to that Sense restaurant. I think that concludes my session. So any questions? Okay, thank you.